Hello, 7th graders. We're going to continue our discussion with probability, some more of these multi-stage experiments. This particular problem that you see right here, it's actually featured on exercise 24. It relates to it anyway. It's not exactly. You'll see the relationship, though, I'm sure, when you check it out. So the box shown has 2 black balls, 3 white balls. And in this experiment, we're pulling balls out without replacing them. And this is going to be our tree, our probability tree, as we can see right here. You know, all these probabilities, you know, like for 3 white balls in a row, probability is 1/10. A black ball followed by a white ball is also 1/10. Notice at the end here, the probability winds up being 1. Well, that makes sense because we're actually out of black balls on that branch. Makes sense? So now with this, I mean, we could, you know, answer a question and say, what's the probability of the last ball being black? Well, last ball being black, I'd just simply say, oh, 1/10, 1/10, and 2/10. You just add those probabilities together. Understand? Okay, moving ahead. Now, if we do a different type of experiment, and each time we take a ball out of the box, throw it in here, and next, after that's thrown in there, we randomize and draw again and put in 3 and randomize those. And draw again out of 3. Now it's interesting here because this time we're looking for what's the probability the last ball is going to be black. Well, in this case, you'll notice it's quite difficult here. If I pulled a white ball out of the bin number 2, I'm never getting a black ball. So, but here's all the ways we could do this. And anytime you're asked to make a tree, kids, always start at the top and say, okay, what's my first draw? Well, it could be black, it could be white. 1/3 black, 2/3 white. So when I throw that in, now I'm looking at this, so I'm doing this bin. That's now, there's 2 different branches of probabilities, because if I threw a black ball in there, now it's 50-50 chance. If a white ball goes in, now it's 3/4 of a chance that it's white. So and then finally do this last one here for this last box. That's going to be, again, there's basically 6 sets of probabilities. Oh sure, this one's missing a branch, but that's because this other branch, the probability of getting a black ball is 0. Understand? So I don't need to include that. I'll just leave it off. All right. So the event that the last ball is going to, in fact, be black contains these outcomes. Where all 3 of them were black, or it went white, and then the last 2 were black. Add those, multiply them out, add those probabilities together, and you get 1/12. Understand? So let's practice this here. If 3 balls are drawn from this box without replacement, draw the tree of this experiment. So again, layer 1, draw yourself a nice pair of branches here, black one, white one. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I miscount? No. Yeah, I did. Yeah, I did miscount. Wow. That's 10 there, isn't it? Because I count 7 white, yeah. Sorry about that, kids. Okay, fine. Happy little accidents. 3/10 of the time it's going to be black. 7/10 of the time it's going to be white. All right, next branch. I've got, again, it could be black or it's white. Now, if I've pulled out a black ball, there's only 2 of them left. So that's 2 out of 9. The remaining ones will be white in that case. That's 7 out of 9. Now, if I pulled out a white ball first, if a white ball's missing, so again, these are both out of 9, but now instead of 7, there's only 6 of the white ones left and 3 of the black ones. Now, of course, as you're going, feel free to reduce these. Say, wait a second, that's 1/3, this is 2/3, and fine. Excellent. So now over here, I'm gonna make gotta make my third draw. So I'm down to 8. Down to 8. If a black one came out, there's only 1 left, and there'd still be 7 of the white ones left. And again, denominators on these are going to be 8s, sure, because now if I pulled out a white one, there's only 6 of those left, and there's still 2 black ones left in that event. Obviously, these numbers will reduce as well again, so I'll just say, okay, I'll reduce that to a 1/4. I'll make this look like 3/4. All right, so and then we're just keep on going here, kids. Um, again, this is, let's do it in black. I should keep it in black. 8 balls left. If a white one's out and a black one's out, well, let's see. That means there's got to be 2. The black ones left here and 6 of the white ones. Again, I can reduce those. And yeah, I'm just kind of angling these because I don't want to run out of space. So 5/8 of the time, the white one will come out on this end. 3/8 of the time, I'll get a black one. So again, that's how you generate your probability tree. So that's simple. So now we can answer questions about it. What's the probability of drawing 3 white balls? Well, that's only going to be, as we can see, there's only one way to do that, and that's this route right here. And so we can multiply to figure that out. 7/10 times 2/3 times 5/8. Use what you know about math and fractions, kids. 2 times 5 you know is 10, so we can cancel those out. 7 doesn't divide 3 and 8, so that's going to multiply out to make 7/24. Now the probability of drawing out exactly 2 of these black balls here, well, that's, as you can see, exactly 2. That's going to be, and I'm just going to change my color here if you don't mind. 2 black balls. That would be one way to do it. This would be one way to do it. And this would be one way to do it, right through here. So let's do some math. 3/10 times 2/9 times 7/8. 3/10 times 2/9 times 7/8. Yeah, just write it out. And reduce as you go. Makes it 3. I could go a 5 here and a 1 here. This is all looking like 7/120. Okay? In a similar fashion, cut right to the chase here. I'll tell you this one's also 7/120. And so is this one, by the way. You can check the math yourself. So, probability of drawing 3 white balls, I have to add these together. When I add those, probability of, getting those, what am I trying to say? Probability is going to be, 7/120 plus 7/120 plus 7/120. Or you could just simply say 3 times 7/120, which of course is going to be 7/40. You can just kind of cancel that, right? So, now this last question here, I said, what's the probability of drawing at least 1 black ball? Now pay attention. You can use one of the first 2 answers to find this probability. You can. And that's because the probability of drawing 3 white balls right here, that is the only one that excludes a black ball from the draw. So therefore, take the complement of that probability. That is to say, again, we call this a complement with an E-M-E-N-T, not I-M-E-N-T. I'm not telling it how good it looks. Complementary with a C-O-M-P-L-E. That's how you spell it with when you're completing something. Complementary probability, please. 1 minus 7/24 is 17/24. Okay? So, next section here, it's just called waiting for a white ball here, it said. Balls are drawn at random 1 by 1 until a white ball is obtained. So, let's find the probability that the white ball came out on the first, that it came out on the second draw, that it came out on the third. See? So, this one's quite simple. That's just simply going to be 1/2. On the second draw, so this is your first. But you got it on the second draw, it had to be 3/10. 1/2 times 3/5. That you didn't get it till the third draw. 1/2 times 2/5 times 3/4, that's 3/20. And that it didn't happen until the fourth draw was going to be a 1/20 probability when you multiply those together. Let's see. So, move ahead here to this little section. This relates to exercise 35, A and B. In fact, congratulations for watching this, because if you watch this screencast, you're going to say, oh, look, this was the answer to the problem, and here it is. Talks about a symmetric die. I would tell you each branch in here has a 1/10 probability. since we're trying to find a sequence where a second number is larger than the first two, yeah, all I could just kind of consider that the probability of getting a digit that's less than 1/10. So let's say, when our middle digit is 1, the probability of the other two being less than it's going to be 1/10 quantity squared. If the one's a 2, well, there's two numbers below 2, a 1 and a 0. And that's going to be 4 over 100. And this will be 9 over 100. 16 over 100. When it's 5, there's 5 numbers below it, 4, 3, 2, 1, and 0. And yeah, so that's going to be 25 over 100, and so forth. All the way down to this last one here, the probability that the other two numbers are smaller is going to be 81 out of 100. So you just add these all together here, kids. I'll cut right to the chase. 285 over 1,000. See? Which, as a decimal, obviously is 0.285 or 28.5%. 35B is the same kind of thing. Again, now we'll think of the middle digit first, getting generated first. So in this case, we can actually rule out the 0 right away, because I'm trying to come up with increasing order left to right. Because obviously the middle number is 0, that it doesn't matter what the left one is, it's never going to fit. So with these, I'm going to consider that if the middle digit is a 1, first number has 1 in 10 chance of being less than it, while the last number has an 8 in 10 chance of being less or greater than a 1. So the second number here, well, what's the the middle number is a 2, right? Okay, so probably the first number is below it is going to be 2 out of 10. That the second number is going to be above it is 7 out of 10. 3, 4, 5, 6, 7, 8, and 9 are all bigger. You're going to wind up, multiplying these together. So if I say, 1/10 times 8/10 in this case. Okay, 1/10 times 8/10, that's 8 100ths. And of course, the probability that we did that was a 1/10 in the first place. So each of these I can just think of as having that 1/10. I don't think I actually just showed that up here, did I? That's okay. But yeah, in the end, this is going to be 8 out of 1,000. This is going to be 14 out of 1,000, and so on down the line. The ones where it's actually the greatest probability you'll find is 20 out of 1,000 here and 20 out of 1,000 on this one. 18 out of 1,000. There you go. And ultimately, when you add up all of these together, by the way, this last one's going to be 0, you wind up with 120 over 1,000, which of course reduces to 1/1200ths, or simply 0.12. So that's going to be the probability that that the numbers are going to be in increasing order left to right. Only a 12% chance. Not many. Final one here, exercise 33 that I'm going to discuss. Here's the tree already drawn out for you. Yay. What you're asked to do on exercise 33, so if you draw three socks blindly out of the drawer, what's the probability that they're going to match? So I'm looking at these probabilities. There's brown, blue, and yellow socks. All of these here are going to, all these branch ends that you see right here, all end in a match, right? Now, if you're thinking about this, though, of course, you say, wait a second. So what would have to happen if there was not a match? Well, that's why I ask this right here. I say, this might be easier to do if we consider there's simply 6 ways to do this, and to pull 3 non-matching socks, and each with the same probability. Yeah, so 13/17. Consider that this is simply 1 minus 4/17. Sorry, 1 minus 4/17 here is in fact 13/17. The answer, I said, that's the probability of a match. Well, there's 6 ways to pull out a 3 non-matching socks. Think about it here. Probability of a brown would be 2/9 times probability of a blue is 6 out of 17 times probability of some yellow one is 1/2. And that is going to get us 2 over 51, except there's 6 ways to do it. So multiply times 6, you've got 12 over 51, and that's where my 4/17 comes from. See? So thus, rather than computing the whole tree and actually calculating all these and adding them together, you get to get 13/17, you can just say the complement of the drawing a non-match. So I'll just label this right here, call it non-match. Great. Sorry for the extensive cast here, but I wanted to give you some help with this. You're going up through exercise 35 today, and for exercise 31, remember you're going to need to do expected value. Remember how we did that on the dice game on the first lesson I gave? Hope you do. All right, that's going to be it for now. I've talked way too long. Have a great day, and I will talk to you tomorrow. Bye now.